Example 19. What is this lost? Okay. Yeah. Yes, okay. Example 19. Now, given that, okay, let's read the question. Okay, let's spend about 10 seconds to read the question. Why is this? Wow. Let's do one thing at a time, okay? We show this. Wow. Looks difficult, right? Okay, can we try and do this, okay? Look at, whenever it's a show question, look up. Whenever it's a show question, you definitely must look very carefully at this and aim towards the answer. You don't blindly, I want this, I just differentiate and do my own way, and then in the end you get a messy looking thing. Follow what I'm saying? So, first, you want to get here which contains d3y dx cubed. Keep an eye on that. You need to differentiate at least 3 times. No choice. But how do we differentiate 3 times? Never mind, at least we differentiate first time, which is not difficult. We will differentiate dy dx. Can we practice chain rule? Why don't you write this? If I will tell your tutors if you cannot do this differentiation. That means tutorial 8 not done well. Okay, come, let's do this. 30 seconds. dy dx, in terms of x, come. You need to refer to formula list, right? Okay, I help you. I don't need to think. I help you. I'm quite kind. Today I'm quite kind. Last lecture already, very kind. This is in formula list. I tell you first, like that. I think you need this. Yes. Right? Okay. Then with this, you can fill in the box. Okay? Differentiate e to the power of x, what do we get? E by x, right? Differentiate e to the power of 2x, what do we get? 2ex, very good. So, 2x, sorry. So, differentiate e to the power of something. Use chain rule, and you should get something. Cannot. Differentiate x. What do you get? How do you get this? Okay. I say this, Ayo, goodness. See. You differentiate e to the power of x, you get e to the power of x. Differentiate e to the power of 2x, what do you get? You get 2e2x. Differentiate e to the power of something. You get e to the power of something, and then you differentiate that something. Because this 2 is gotten from a differential of 2x. You differentiate 2x, you get 2. You follow what I'm saying? Chain rule. This is chain rule, right? Okay, so the next line should be simple. You will, in fact, you see the next line, you will get answer lah, but never mind. You will get e to this 2 over 1 plus x squared. Can? Okay, now I need you all to look up. Imagine you are the one doing the question. Okay? Imagine you are the one doing the question. And you need to prove all the way here. You know what most of us will do? Don't look below, okay? You know what most of us will do? You will just, I want d3y, I differentiate this from here. I tell you, you're gonna have a very, very hard time if you stop here and then you just differentiate one more time, be 2y dx squared, because this is not easy to differentiate and you get a very messy looking expression. Which is why I say, for show questions, you must always keep an eye here. There clearly isn't any E2 tangent inverse x at all here. You follow what I'm saying? So the trick here is to simplify this a little. How do we simplify? Look, the next step, I multiply across by 1 plus x squared, I get this. And then I get a 2E2 tangent inverse x. Here, I immediately substitute this into y. I get this equals to 2y. Now, this is important. Can you have attention, please? Do not stop here. Why? Because this is the result that you want to prove. This result hasn't got e to the power of tangent inverse 2x. E2 hasn't got e to the power of 2 tangent inverse x. Follow what I'm saying? I want to introduce this some manipulation to introduce the y. Once you get this, I think it is easy from now onwards. Why? Because now you have a y, it's easy to differentiate. You differentiate y, you get dy dx. Follow what I'm saying? Yes? I say it many times, many of us are very comfortable with just make dy dx a subject and then right hand side all x. You must be comfortable with this kind of implicit differentiation. Okay, so from next line, I'm going to differentiate with respect to x in the next line. If you are fast, you can actually do it. From here to here is product rule. Product rule, yeah? Then you get keep 1 plus x squared. Differentiate dy dx, you get d2y dx squared. Differentiate 1 plus x squared, you get 2x. You keep dy dx. Differentiate 2y, you get 2 dy dx. All follow? All follow? This is product rule. Then from there, all I do from the next, this here to here is to minus on both sides by 2 dy dx, bring this across, I get something like that. Now we cannot stop here because we actually want a result with the 3y dx cubed. Never mind, differentiate one more time. And we get answer. Okay, why don't you all do? Can you all do this? Hey. What is that? Anyway, yeah, this computer giving problem. I want a cry worm, is it? It's telling you something? Why is it telling you and not telling me? Then what? Then we should stop here? Are you kidding? Come on. You don't know about the I want to cry worm or not? Don't know ah? I want to cry the ransomware over the weekend. Yeah, no, yeah, and you all read the news or not? Ayo. But then after that, after that, a student emailed me, and told me that actually he or she got infected by that. His kid's computer really got infected. I want to share the experience with all of us, if he or she allows me. Okay, anyway. Product rule. Give it one more time. This is also product rule. Don't talk. Just do. Do. I'm not going to show you the answer. You should have 4 terms, yeah? Something plus something plus something plus something. Right. 4 terms. 4 terms. Product rule. Okay, 4 terms. Let's write down the 4 terms. Keep 1 plus x squared. Differentiate, you get the 3y dx cubed. Differentiate this, you get the 2y dx squared. Keep this. Sorry. And then differentiate this, you get 2. Why can't I erase this guy away? I cannot erase. Ah. Ayo. Okay, can. Alright, you get those 4 terms. After that, you get there and you show. Okay, look up. Easy for us to say. Easy for us to follow step by step, guy. Can you tell me, in all these lines here, which line is the most important? Here is here. This is the most crucial here. Had you stopped here, and you do repeated differentiation, gone. You follow what I'm saying? 笑了, correct. Here to here is the killer move. Here. Right? Okay? Now, after you have shown that, okay, now we have shown, thank you. Hence or otherwise, find the Maclaurin's expansion for y up to and including the term in x cubed. So we got to keep. So we have to find what is f0, f prime 0, f double prime 0, f triple prime 0. How? Very simple, right? Just substitute. F prime 0 means you substitute x equals to 0 into here. You will get a 2. Sorry, not what 2 I'm talking about. E to the power of 2 tangent inverse 0. Correct? What is tangent inverse 0? Is 0. So you get e to the power of 0, which is 1. So we have found that f0 is 1. Now we need to find f prime 0. Correct? Now, can I have attention? Please don't look up. You could have, there are 2 ways to do it. 1, you could have substituted 0 in, you get here 0, 0, then you get dy dx. No problem, you'll still get the same answer. Or, you could have said, oh, okay, when x is 0, y is 1, you substitute into this expression to find a dy dx, which is a little bit simpler. Follow what I'm saying? Because when x is 0, y is 1. You have should this the f0 is 1. So substitute into this. Can we substitute into this? I prefer that. So I substitute that. I get 1 plus 0 square dy dx equals to 2 times 1. Therefore, f prime 0 is just 2. Can? Now, what about the next one? To get f double prime, I'm going to substitute into. Whoa, just I'm going to substitute into this. Because when x is 0, dy dx is 2. So we get 1 plus 0 square d2y dx square plus 2, 0 minus 1 dy dx is 2 equals to 0. I hope you know where I get this from, okay? It's actually gotten from here. Alright? Then f double prime 0 is just 4. Yes? Oh God? So to get f triple prime, you actually substitute into this. Quite brainless actually. Quite easy. Then you get 1 plus 0 square d3y dx cubed plus 0 minus 2, 4 plus 2 dy dx is 2. F triple prime 0 is just 4. 6 man? 4 lah. 4. Quite simple once you got that. Okay, can? So, you can answer. Just recall recall MF26 fx is f0 plus f prime 0 x plus f double prime 0 over 2 factorial x squared plus f triple prime 0 over 3 factorial x squared, x cubed, sorry. So, substitute in, I get 1 plus 2x plus x squared over 2 factorial times 4 plus x cubed over 3 factorial times 4. Can you all don't forget your plus dot 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 because it's a never ending series. Alright? Take answer.